Hi, this is Mrs. Rodriguez, your geometry teacher. This video is a review for the Chapter 10 test that's coming up. Some of these questions are from a practice test on page 771 in your textbook. Most of them I have to go looking for them throughout your textbook, okay? So as you're watching this video, when a problem comes up on the board, please pause the video, try to solve the problem yourself, and then listen to the explanation. If you get the problem correct, great, move on to the next problem. If you get to the end of the video and you got some problems wrong and you don't understand my explanation, please call, text, email, or stop by my office hours, and I'd be happy to help you go over those problems so you can get clarification. Okay? All right, let's go ahead and get started. So like I said, this is a review for the Chapter 10 test. All right, so first lesson talks about circular circumference. The whole chapter is about circumference, but first lesson is about circumference. And the circumference of a circle is equal to pi times the diameter, or 2 times pi times the radius. It just depends on what information you have. So a radius is a segment with endpoints at the center and on the circle, okay? So from the center out to the circle, okay? So CF is a radius, CD, CER is a radius. AB is not a radius because it's not touching the center. A chord is a segment with endpoints on the circle. So like AB is a chord, and so is DE because it's going from one end of the circle to the other. Here, same thing with AB, one is touching one end of the circle and another end, okay? The diameter of a circle is a chord, so like DE is a diameter, and it's also classified as a chord, okay, that passes through the center and is made up of a collinear radii, okay? All right, so Amanda's family has a swimming pool that is 4 feet deep in their backyard. If the diameter of the pool is 25 feet, what is the circumference of the pool to the nearest foot? Okay, so remember, circumference is equal to pi times the diameter, or the circumference is equal to 2 times pi times the radius, okay? So we're given the diameter of the pool, so we can use this formula here. Circumference equals pi times the diameter. So then we would plug in 25 in for pi, for the diameter, and then multiply by pi. And you do that in your calculator. And when you do that, you get about 78 and 53/100ths. And it says to round to the nearest foot. So that would be 79 feet, right? Because we have 78.5, so we would round up, okay? All right. Next one, our next sections talk about angles, arcs, chords, and inscribed circles. Okay, so this you need to know a few things. The sum of the measures of the central angles of a circle is 360 degrees. Okay, so all the angles within a circle add up to 360 degrees. The length of an arc is proportional to the length of the circumference. The diameter is perpendicular to chords, bisect chords, and intersected arcs. And the measure of an inscribed angle is half the measure of an intercepted arc. Okay, so here it says to find the value of x, okay? So, all right, so here it says to find the angle of x, okay? We know, we just read that all the angles within a circle add up to 360 degrees. So this angle, this angle, this angle, this angle, and this angle would all add up to 360 degrees. So you have to add all those together. 167 plus x plus 77 plus x plus 26, and that should equal 360. And then when you combine your like terms, you end up with a two-step equation, 270 plus 2x equals 360. You would subtract 270 from both sides, then divide both sides by 2, and you get that x is equal to 45. Okay, so here we know that we're being asked for x. Okay, so we're looking for this angle. We have this diameter, right? So if all of the angles within a circle are 360 degrees, and here we have this diameter that cuts it in half, well, half of 360 is 180 degrees, right? So these angles right here should total 180 degrees. So this angle x plus this angle, which we know with that symbol, that's 90 degrees, okay? And then this angle is 67. All those angles should end up being 180 degrees. So we we combine our like terms, 90 and 67. We get x plus 157 equals 180. Then we subtract 157 from both sides, and we end up with x equals 23 degrees, okay? So section 10-3 talks about arcs and chords. So here we have this circle, and it says in circle E, EG and EF are equal. Find AB. So we want the length of this here. So since chords EG and EF are congruent, they are equidistant from E, okay? So that means these chords AB and CD are equal to each other in length, okay? So if we know that, we can set this expression equal to this expression and solve for x there. And then so x is equal to 12, and they want to know the length of AB. So it's not 12. You have to plug in 12 into 3x minus 9, because AB is 3x minus 9. So they did 3 times 12, subtracted 9, and then the answer would be 27. Okay? So if you have two chords that are the same distance from the center, then the lengths of those chords are congruent. Okay? So if you're given these expressions, you can set them equal to each other. Okay? All right, so here it says to find x if circle M is congruent to circle N. So here we can see, since these circles are congruent and this mark tells us that these two lengths are the same, are equal in length, then we can set this expression and this expression equal to each other. And then we can solve for x here. So I would subtract 2x from both sides. I get 0 equals 3x minus 27. Then I would add 27 to both sides, and I would get 27 equals 3x. Then I would divide both sides by 3, so 9 is equal to x. So it's just asking for x, but if it asked for the length of ST or of UV, then you would plug in x into these expressions, okay? But since it was only asking for x, we can stop here, okay? All right, and then here's an additional problem. This problem I think I pulled from the study guide. Okay, so it says here in circle K, MN, this distance from here to here, is equal to 16, and the length of the arc, MN, is equal to 98. Find each measure, round to the nearest 100, okay? And we're looking for the measure of NJ. So this from here to here, okay? So first thing we notice, here we have a diameter, right? This is a diameter. So we're also told, so half of the circle is on this side, the other half is on this side, okay? We can see here that this chord is perpendicular to this diameter, okay? So that means it bisected the chord and intersected the arc here. So in other words, since we know this is 16 from M to N, this is going to be 8, and this is also going to be 8, right? So, and then we're also told that this MN is equal to 98, okay? So all the way around would be 360, right? So 360 minus the measure of arc MN is going to be equal to this arc MJ and also NJ. And these are going to be congruent to each other, okay? Because this diameter split it in half, and then half of it is over here, okay? Half of it is here. So this distance, since we know all of this, half of this would be this section, and then the rest would be this, okay? So we have 360 minus the measurement of arc MN is equal to the measurement of arc MJ plus the measurement of arc JN. Okay, so we fill that in with the values we're given. So that's 360 minus 98. And then I'm just going to call this, since these are the same, I'm just going to call this 2x. So it's just 2 of the same value. And then 360 minus 98 is 262 equals 2x. And then I would divide both sides by 2. And I get 131 equals x. Okay, so the measurement of the arc of NJ is equal to 131. Okay. All right, so here it says to find each measure, okay? We're given that this is 218 degrees. And if you look back, it told us in the key points here, the measure of an inscribed angle is half the measure of its intercepted arc. Okay, so this angle here, angle 1, is inscribed in this circle. So it's going to be half of the intercepted arc. Okay, so the intercepted arc is 218 degrees. So we're going to divide that by 2. And when we do that, we get 109 degrees. So the measurement of angle 1 is 109 degrees. Okay. So far, the math that needs to be done is not too complicated. You just have to remember all of the rules and the theorems and things like that that are stated in this chapter and know when to apply each one of them, okay? So here it says to find the measure of angle D and angle B, okay? So you need to know, we have this ABCD is inscribed in a circle. So knowing that opposite angles are supplementary. So angle B and angle D are supplementary. Remember, that means they add up to 180 degrees. So you would set this expression 2x minus 8 and 3x plus 12, add those together, and you should end up with 180 degrees. So the combined like terms here, 23x and 21x is 44x, 12 minus 8 is 4. Then you would subtract 4 from both sides. You get 44x equals 176. Then you would divide both sides by 44. So x is equal to 4. But remember, it wants the measurements of each of these angles. So angle D is 23x plus 12. You just figured out that x was equal to 4. So 23 times 4 plus 12 would give you 104. And then for the measurement of B, 21 times 4 minus 8 would be 76. Okay? So make sure you are rereading the question after you think you've answered it so you know you've answered the correct question. Okay? Because if this was a multiple choice question, x equals 4 will be one of the answer options. And you'll think, oh, x does equal 4, that's true. But you have to pick the answer that answers the question that's being asked, okay? All right, so then the next two sections talk about tangent, secants, and angle measures. So a line that is tangent to a circle intersects the circle in exactly one point that is perpendicular to the radius. So you have a circle, okay? Let's say here is the radius, and then there is a line that touches right on that point, and it's perpendicular, right? So this would be a 90-degree angle, okay? And then two segments tangent to a circle from the same exterior point are congruent. So if we had a point out here, okay, and it was touching, these two lines were touching the circle, this would be congruent to this, okay? And then the measure of an angle formed by two secant lines is half the positive difference of its intersected arcs. And the measure of an angle formed by a secant and tangent line is half its intersected arc. Okay, so here in the figure, it says KL, so that's from here to here. This line here is tangent to circle M, okay, at K. All right, here is the 90-degree angle right here. Find the value of X. Okay, well, then this means this has to be a 90-degree angle, right? So going back, I think the last chapter talked about the Pythagorean theorem, right? So this is a right triangle. So we know that this side right here, X squared, plus this side here, 17 squared, would be equal to this side, X plus 10 squared. Those would be equal to each other. So we plug in X squared plus 17 squared. Remember, this is A squared plus B squared equals C squared. And C in this case, we know from here to here is X, and then from here to here is 10. Okay, so this would be X plus 10 squared. So you would use the FOIL method and multiply that out, and you end up with X squared plus 289 equals X squared plus 20X plus 100. So then you would subtract X squared from both sides, and you end up with 289 equals 20X plus 100. Then you would subtract 100 from both sides. You get 189 equals 20X. And then you would divide both sides by 20, and 9 and 4500 is equal to X. Okay? All right, so let's look at this problem here. It says determine whether FG is tangent to circle E. Justify your answer. So remember, in order for this line to be tangent, it has to form, this would have to be a 90-degree angle, and this would have to be a right triangle. Okay, so we're using the Pythagorean theorem to see if this squared plus this is going to be A, this is going to be B, and then this is C, because this is the longest side, right? Okay, all right, so A is 17, and we're going to square it. B is 26, and we square it. And C is 30, and we square it. So when we do that, 26 squared, 17 squared is 289, and 26 squared is 676, and 30 squared is equal to 900. So we add 289 and 676, and we get 965, which is not equal to 900. So no, this line is not tangent to this circle, because this triangle is not a right triangle. Okay? All right. So this one here, it says to find X and Y. So here are the X's, and then here's Y. Assume the segments that appear to be tangent are tangent, round to the nearest tenth if necessary. Okay, so if this is tangent, if this line is tangent to this circle here at this point, then that means this is a right angle, and that means this is a right triangle. So this can be the value of A, this can be the value of B, and that would make this C. Okay, so we use the Pythagorean theorem. We're going to plug in the values. A is Y, B is 39, we would square that, and C is 41. We'd square that. So y squared plus 39 squared is 1,521. 41 squared is 1,681. We would subtract 1,521 from both sides, and we end up with y squared equals 160. So then what we would need to do to find y is take the square root of both sides. So y is about 12 6/10. Okay, so that's the value of y. Then we also need to find the value of x, right? So we're told that if we have a point outside the circle and these lines are tangent, okay, this line is tangent, and this one, then the lengths are going to be equal to each other, okay? So two segments tangent to a circle from the same exterior point are congruent. So this is equal to this. So I would put 5x minus 8 equal to 72 minus 3x. And then I would solve this equation. First, I would add 3x to both sides, and I get 8x minus 8 equals 72. And then I would add 8 to both sides, and I get 8x equals 80. Then I would divide both sides by 8, so x is equal to 10. So I solve for x and I solve for y. So I'm all set with that problem, okay? All right, so then the next section section 10-6 talks about secants, tangents, and angle measures. So here it says to find the value of x right here. And it says arc CAB, so that's this arc here, is a semicircle because CB is the diameter. So the measure of arc CAB is 180, right? It's half of the circle. So the measurement of angle D is equal to half of the measurement of arc CB minus arc EB, okay? So the two intersecting arcs, right? And this is because if two secants or chords intersect in the interior, no, it's because, okay, the measure of an angle formed by two secant lines is half the positive difference of its intersected arcs, okay? So that's why it's half of this and this, because this angle, this 45-degree angle, intersected this arc and this arc here, okay? So the measurement of angle D is 45 degrees equals half of the measurement of arc CB, which is 180, because it's half of the circle, minus the measurement of CB, which is 10x. Okay, so we would distribute 1/2, so half of 180 excuse me, what they did is they multiplied both sides by 2 first. And then they got the 90. So they multiplied this by 2, okay? And this by 2, and that eliminated the 1/2. So then they got 90 equals 180 minus 10x. Then they subtracted 180, and that's how they got the negative 90 equals negative 10x, and then they divided by negative 10 and got a positive 9 there. So that was the value of x. Okay, so here it says to find each measure, assume the segments that appear to be tangent are tangent. Okay, so here we're asked for the measurement of angle 1, this measurement right here. Okay, so we have these two secants, or these two chords, that intersect in the interior of a circle. So then these measures of angle are formed, the angles formed is half of the sum of the measure of the arcs. Okay, and okay, so the measurement of angle 1 is going to be half of this plus this measurement. Okay, because it intercepted this arc and this arc. Okay, so we would take 108, add 86, and then divide that by 2. Okay, so when we add 108 and 86, we get 194. So then we would divide that by 2, and we get 97. So the measurement of angle 1 is equal to 97 degrees. Okay, and remember, that's because if you have two chords that intersect each other, then the measurement of an angle formed, which the angle formed was angle 1, that measurement of the angle formed is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay. All right, so next one, special segments and equation of a circle. So the lengths of intersecting chords in a circle can be found by using the products of the measures of the segments. And then also the equation of a circle with center HK and radius R is x minus h squared minus y minus k squared equals r squared. Okay. So here it says find the diameter of circle M. Okay. So going back to what this just said here, it says the lengths of intersecting chords in a circle can be found by using the products of the measures of the segment. Okay. So if two chords intersect in a circle, then the products of the lengths of their chord segments are equal. Okay, so for example, segment VW times WX is going to be equal to YW times WZ. Okay, so that would be 17 times 17 is equal to 10.5, this segment, times the length of this segment, which is WZ. We don't know. So they plug that in, they get 289 is equal to 10.5 times WZ. So then you would divide by 10.5, and you get 27.5 is the length of WZ. So that's just this side here, right? So now we know the length of this side and this segment here, so you would add those together, and you end up with the diameter being 38. Okay. All right, so here it says to find x, so this is the same type of problem. So I would multiply this segment times this segment, so 6 times 3 would equal this segment, 2 times this segment, 2 times x, so 6 times 3 is 18, here's 2x, and then we would divide both sides by 2, so 9 is equal to x. Okay. All right, and then here it says to write the equation of the circle graph below. So first thing, we need two pieces of information in order to write the equation of a circle. And those two things are the center, the coordinates of the center, and then the length of the radius, okay? So looking at this circle, the center is this point here, which if we look, that would be, notice that these are multiples of 2, so that's 2, 4, 6, and then up to 4. So the center is at 6, positive 6, positive 4. And then the radius would be from here to here, right? So it's 2, 4, and then half. So that would be 1. So that's 5, right? So the radius is equal to 5. So remember, the equation for a circle is x minus h squared plus y minus k squared equals r squared. And the center is hk. So we plug in 6 in for h, we plug in 4 in for k, right here, and then we plug in 5 in for r. And then we can't simplify this, so but we can square 5 and we would get 25. So this would be our equation. Okay. So here it says write the equation of each circle. Okay, so remember the equation of a circle is x minus h squared plus y minus k squared equals r squared. Okay. So first we have h and k, right? So h is equal to 1, k is equal to 2, and we're given that the diameter is 14. So that means that the radius is 7, right? Half of the diameter. So we plug in that information. So x minus h, which is 1, squared, plus y minus k, which is 2, equals r squared, which is 7. And then we know r squared is 49. So I'm just going to rewrite this. So x minus 1 squared plus y minus 2 squared equals 49. That's our equation there. All right, then for this one, it's now we're going backwards. It says find the center of the circle whose equation is x plus 2 squared plus y minus 4 squared equals 25. Okay, so remember the equation of the circle is x minus h squared plus y minus k squared equals r squared. So the center is what's being subtracted from x, right? Well, here it says x plus 2. Okay, well, how does that happen? How do we go from subtracting something to adding something? Well, they added the opposite, right? So this was x minus negative 2, right? Because if you add the opposite, that would be x plus 2. So that means h is equal to negative 2. And then here we had y minus 4, so k is equal to 4. So then the center of the circle is at negative 2, positive 4. If it asks for the radius, it would be the square root of 25, which is 5. Okay? But this one just asks for the center. Okay? All right, so that's all I have for you for the review for this chapter. So if you got to this point in the video and you still had some questions, please make sure that you call, text, email me, or stop by my office hours, and I'd be happy to help you figure the problems out and discuss what the issue is. Okay? All right, so you have a great day and good luck on your test.